All right. Hello, everyone. My name is Richard, and I'll be running this advanced SolidWorks workshop for today. So if you guys haven't watched the previous workshop video, that was basically giving a general idea of SolidWorks and using some basic features and sketches within the software. This time we're going to go more in depth with other types of features that are more advanced, and we'll be making a more complicated assembly as well. So first off, if you guys have seen the description, we're basically creating a crank slider that has a two-linkage system. So we're gonna be creating each of those parts right now. And first off is I'm gonna create the wheel. So remember when you first enter SolidWorks, you have to look at your units. In this case, I'm using mmgs this time, millimeter gram second, on the bottom right. So I am already in a parts section, so I'm going to create a sketch. So I'm going to create a sketch on the right plane. So if I can click on any of these planes, I'm going to click on the right plane, and it's going to adjust automatically. So what I'm trying to do here is I'm trying to incorporate this revolved boss base feature into creating that wheel. So how I'm going to do that is I'm just going to create a center line. So get a center line, start from this point of origin, and I'm going to drag up. All right. Once I drag that up, I'm just going to use the line feature, and I'm going to create kind of like this T, like half a T shape. It's going to look something like this. And all of these should like automatically click or lock in place if you see the lines. So we can zoom in a bit and you can see that these green squares show relations. So it's what I'm going to talk about later on, and it just shows you that something's horizontal or something is vertical. So now we have this. What I'm going to do is I'm going to smart dimension this shape. So remember, we're having this in terms of millimeters. So I'm going to do 5 millimeters on the bottom. So remember, once these blue lines were undefined, they become defined when you give it some dimension. Next up, I'm going to make this dimension 45 millimeters.
Richard, we have a question of which face did you start the sketch on?
Yes, so I started the sketch on the right plane. Yeah. So we'll continue dimensionalizing these other sides. These are like any numbers you can choose, but I made this beforehand, so I'm just going with or sticking with the dimension I have. Okay, so if you can see here that before you had a fully defined sketch, let's say you made a mistake and added an extra dimension here, it's going to over define it like this and it's going to make it yellow. So this would be overly defined. So you cannot have this. So this is what you should have in the end. So we have 5, 45, 5, and 5. All right, so I'm going to create next is a mirror entity. So I'm going to use this feature, mirror entity, and I'm selecting, so how I can select these lines, so entities to mirror. I'm going to hold shift, the shift key, and I'm going to click on all these lines that I want to mirror. And it only works when you hold the shift key. And I'm going to mirror about this center line that I created. Okay, so I mirror that. So now I have a preview of what that looks like once I click the check mark. So now I have this T shape. All right, so this is fully defined. I can exit the sketch, and then I can use my revolved boss base feature. So I click on this, and it's going to ask me what line, or what is my axis of revolution? So it was clicking on the center line, but we don't want to use a center line. What I'm going to use for the axis of revolution is this bottom line right here. So this bottom line. So once you see that, your cross section of your sketch will revolve about that bottom line. So that is essentially the center of your wheel, and it just rotates around. So you will see that preview. All right, so you click OK, and now you have the basic shape of a wheel. All right, so we're gonna rotate uh, our face so we can see this side. Next, what I want to do is I want to create a sketch, and this is going to ask me where I want to sketch. I'm going to sketch on the inside face, right? Because you can see this is kind of like the outer side. We want to sketch on the inside. So I'm going to click there. And what I'm going to do is I'm going to create some holes into it. So I'm going to use the circle feature. I'm going to click the point of origin, and I'm just going to drag out. So now I can smart dimension this, and let's say we'll give it 8 millimeters. Okay, so next up, I'm going to create more circles. So I'm going to use a center line. And this center line, I'm going to start from the very center and drag out. So now I have the center line. I am going to create 2 more circles that are going to be on here. So you could just put 2 more circles on that center line. And then you can use your smart dimension again. And I'm going to give it another 8 millimeters again for these 2 circles. Okay. So next up, you can see that these are still underdefined. So you have to give a distance in relation to the point of origin. So in this case, I'm going to click the center point of both of these circles. And I'm going to dimension that. And I'm going to say it's going to be 18 millimeters. And now it shifts to the right because you know this is fixed because you already fully defined it. So you can do the same with the center of these 2 circles and say it's 18 millimeters as well. Okay. So next up, I'm going to introduce, so if you click on, or click the drop down of the linear sketch pattern, there's an additional circular sketch pattern. And I click on it, and it's going to ask me which parameters do I want to create that circular pattern. I'm going to do it for both of these, but I'm going to do it for individual. So I'm going to start off with the middle one, middle circle. So I just click on that, and it's going to automatically generate the rotation. So it says 360 degrees, so it goes around at 360 degrees, and I'm doing it 4 times. So you can choose the number and adjust it accordingly. And it already tells you what the radius is. We already defined it as 18 millimeters, as you can see here. And we could just go with this, and then we click OK. And then we're going to do it again with the outer circle. So we're going to click circular sketch pattern. Oh, but we're not going to use the same one. We're going to choose this one. Okay. Actually, wait, let me do that one more time. So we're going to do circular sketch pattern, and we're going to click on the outer circle. And it's going to give us 4. But let's just change the number up a bit to 6. So now you see there's 6, and it's equally spaced out like that. And now you can see this one, because we added another 18 millimeters to the 18 before, this shows you that now the radius is 36 millimeters, so that's correct. So you click the check mark, and now you're done with your sketch, so you can exit out, and then you can simply use an extrude cut. So you can now rotate to see if your cut was made correctly. In this case, the inner length is 10 millimeters, so that's correct. So now you can see that you've made your holes in your wheel, like that. All right, so now that your wheel is done, you can save it. So we'll do a save as, and I'll call it wheel. All right, so we saved it. Now we want to create a new part. All right, so next up, what I'm going to do next is I'm going to create a bracket. So this is going to be your fixed bracket. So that's where you're connecting the wheel to all the other components. So what I'm going to do is I'm going to go and sketch, click on sketch, and this time I'm going to sketch on the front plane. All right, so now I'm on the front plane, as you can see from here. I am going to click this middle one. So this is called a center point arc. So I am going to click on the center point arc. So this basically, how it works is I click at the point of origin and I drag out a certain distance and I click on it. So it creates a circle and it tells me, it can give me, or it can create like semicircles like this. So this is what I want and I'm going to click like that. So this is not defined yet, but we're going to give it some value. So for these incomplete circles, so like for the semicircle, if you give it a dimension, it's going to have this letter R in front of the number. It's telling you that you're not looking at the diameter, you're looking at the radius instead. So this is important. So you see that R, you know that you're inputting the radius of the circle, right? So that's done. So next up is creating these other lines. So I am just gonna draw out this, what it should look like. Okay. So you know when you just automatically sketch these lines, it will give you your relations, but you can actually add more relations to these. So let's say I want these lines to be equal. So I'm going to hold shift and I'm going to click on these two individual lines. And I have the option of adding relations here. So I want to make these two lines equal. So I'm going to click the equal in length and it's going to automatically adjust. I'm going to do the same for these other ones. So this one, oops. So I'm going to click it for this one and this one. And then I'm going to use the relation equal. So you can see that it gives you, it introduces new relations here, as shown by the green square. And then we have one more to go, which is these two. All right, so that means it's going to be easier when you can input your measurements. So in this case, this is 8 millimeters. This is 5 millimeters. And this is 3 millimeters. Okay. And then one more thing we need to add is the circle in the middle. So remember, we're connecting the wheel to this fixed bracket with a shaft. So we're creating this hole to connect that shaft together. So the circle has a diameter of 8 millimeters, and we just input that, and that's it for this part, or for the sketch of this part. So now we can exit the sketch, and then we can just extrude boss that. So in this case, I'm gonna just do 5 millimeters for this boss extrude with a blind setup. Okay, so I'm just gonna add some color to this just to differentiate it once we have all the parts in the assembly. So I'm gonna make this black. All right, and that is the end of this part. So we'll save as, and we'll call it fixed bracket. All right, next up, I'm gonna create another part, and that's gonna be the shaft. So this one's just pretty simple. We are gonna look at the front plane, and then I am gonna create a sketch, and I'm gonna just use the circle. So I click in the center or point of origin, I drag out some distance, and I have to give it a dimension. Remember, we gave it 8 millimeter as the diameter of the shaft. And I can just exit the sketch and extrude out. So this extrusion is gonna be 40 millimeters. And that is the shaft. So we'll save it and call it shaft. All right, we're gonna create a fourth part. So this is gonna be our first linkage for this part. So we're gonna go to sketch, and we're sketching on the front plane. And I am gonna use this feature called a straight slot. All right. So what this straight slot does is you basically click, let's say, the point of origin, and it's gonna first create a line. So you can drag it out any distance, and you click again. So now you created a line, and now you have to drag out. So this creates that slot, basically. So I'm gonna drag out, and I get this type of shape. Okay, so now we can dimensionalize it. So I'm going to smart dimension, and for this type of feature, you basically have two different things to dimensionalize. You have to first do the length of this. So first we'll give it, let's say 36 millimeters for the length. Next is you have to adjust this radius of this semicircle. In this case, I'm gonna create it as 6 millimeters for the radius. All right, so those are the two things that you need to adjust for this type of sketch. So I am also gonna include two circles. So these are basically your holes for your shafts. And these are gonna be on the ends of the center line. So I just click on the circle and just give it a dimension, and we said 8mm shafts. And that is it for this sketch. So we extrude out, and we're going to extrude it 5mm again. All right, so I'm going to give it some color, and we'll just give it red. Okay, so this part is now done. So we save as, and I'm going to call it linkage 1. Yeah, so I just want to point out that for all these parts, it might be like just like simple parts, and you might not make sense of why I gave all these specific dimensions, but it all should fit in the end. So what I'm gonna do is I'm gonna actually save as again, because I'm creating two linkages, so they're basically the same shape. So I'm just saving as again. So this is linkage 2. But linkage 2, I'm just adjusting a parameter. So if I go to the sketch, what we sketched before, I can right click on it and edit that sketch. So we stated that these are all correct. So you have the 8mm diameter for the shaft. That doesn't change. The radius doesn't change, but this length does change for linkage number 2. So I'm going to give it a length of 120mm. So it's going to shift out pretty far, as you can see here. So we can exit the sketch, and I am gonna just change the color again. Let's change it to blue. And there's that. Now you have your updated linkage number 2, and you can save. All right, next up is we're gonna create a new part. And what I'm gonna do is I'm gonna create a sketch, and it's gonna be on the right plane. So if I sketch, I am gonna sketch on the right plane. So we're on the right plane. And I am gonna choose the center rectangle to start off with. So I'm gonna click at the point of origin. I'm gonna drag out. And I have basically a rectangular shape. I'm gonna give it some dimensions. Let's say this one is 25mm. And let's say on the height is 21mm. Okay, I'm gonna exit the sketch, and then I'm gonna extrude the sketch. So for this extrusion, I am gonna make it 12mm. Okay, so there's that. And then I am gonna look at this face. So if you look at what we did, before we looked at the right plane, now we're gonna look at basically the front plane. But instead of looking at the front plane, as you can see here where the front plane's at, you're looking at the face that's parallel to the front plane. So this face, I'm gonna click on it, and I'm gonna sketch on this face. So you're gonna adjust your camera, and you're basically creating that circle. Hello, am I back?
Yeah,
Okay, I disconnected, but I am back now. So, like I said, you have to go to centerline. So you're using centerline, and then where this point of origin is, you hover over the point, which is highlighted in orange, and you can drag out, and then you can lock it in. So you have your first centerline, and then you can just use your circle feature because once you put that center line in, you can see that the yellow dot is basically the midpoint. So I'm going to put the circle in. I can drag out, and I can assign it some diameter, 8 millimeters. So I'm done with smart dimensioning, and I can exit. And I'm going to create an extruded cut for this hole. So if you can see we're using blind, let's test out a different one. Let's say through all. Through all basically just goes through all the way to the other side of the block. So we're going to use through all, and then I can see you created that hole. All right, so I'm going to give it a color, and I'm going to just give it yellow. All right, we're done with this part now. So this is what we're going to call it the block. And this block is going to fit inside a rail. So that's going to be our last part we're going to build before we go into the assembly. So let's talk about the rail. So we're going to go, like I said, and into a new part. We're going to click on the right plane, and then we're going to sketch on that plane. We're going to do what we did before. We're going to go to the center rectangle, and then we're going to start from the point of origin and drag out. This time, we're going to be using 25 millimeters by 25 millimeters. Okay. So now that's fully defined, we can exit the sketch and create an extruded boss base. And we're going to give it 86 millimeters. So this is very specific. You'll see why later on. So I'm going to just say 86 millimeters for now and then accept that change. And then this is a new feature that I'm going to introduce. It's going to be the shell feature. So basically, we're inputting a thickness for the shell that we're creating. In this case, I'm going to set it as 2 millimeters, and you'll kind of see why. So this section here is faces to remove. I'm going to remove 3 faces. I'm going to remove this face, so the back face. So if I click on it, you won't see anything, but then if you click show preview, you'll see that now, let's say we remove the face, right? So your thickness is creating a shell. So inside here is hollow, and you could click on the faces here to remove. So if I click on this face, now that thickness is gone. And I'm going to do the same for this front face and the back face. So this front face, as you can see, this thickness is gone, as well as now this back face. So these 3 faces. And then I'm going to accept these changes, and I'm going to get something that looks like this. It kind of looks like a pitchfork or something. All right, so now I'm going to go to appearance, and let's just change the color again. We'll make it black. All right, so now we have this part finished. So I'm going to save as, and I'm going to call this the rail. Okay, so now that's done. We finish our parts. We're gonna now move into the assembly. All right, so when you first open up assembly, remember that you can now access any of your opened documents or parts. So in this case, I'm gonna open the rail, the one we just worked on. So I'm gonna click on rail, and I'm gonna just drag it out. Okay, so now we can rotate our camera view. We can see the rail. And then I can insert another component. In this case, it's gonna be the block. So if I insert it, I can drag it in. So basically what we had before was the height of this rail was 25. We had 2 mm thickness here. So that subtracts 4 mm, which is why the height of this was 21 mm. So when you do this, you can always check your dimensions by going to evaluate and clicking measure to make sure that your dimensions are correct. So in this case, we had assigned this length to be 21 mm, and we can double check this to see if this also matches 21 mm. So the distance from these two lines are also 21 mm. So that's just a check. So now we're going to go to mates, and I am going to mate this face with this face. All right. And then also I'm going to mate this front face of the block with this front face. So remember, you need 3 mates to fix something. But now if we look at what we have, right? This block is supposed to be sliding inside this rail. However, you can see that it can go infinitely in any direction. It just travels in this direction. So how can we limit for this block to go from one edge to, let's say, here? So we can use an advanced mate. So we look at your advanced mates, and we're going to use a limit distance. So what I'm going to do is I am going to click this face and this face. So you have, when you click limit distance, so this limit distance mate, you have this option here where you have a minimum and a maximum value. In this case, your minimum is going to be 0 mm, and then your maximum distance is going to be 72 millimeters. So I believe this is also 72 as well. Yeah. So you click OK, and you should have now a block that only travels from one end here. Like I can't drag it out as I did before, but I can drag it so it's only inside this limit. So how did I get 72? So the mate is always between this face and this face, right? That's what we assigned it. So if I drag it out, right, the total length of this is 86, but then you have to subtract this 2 mm thickness of the shell, and then also the length of this block, which hopefully I can highlight. Yeah, so 12 plus 2 is 14, and then 86 minus 14 is 72 millimeters, which is what we inputted for our maximum distance. All right, so there you have it. So this is our first assembly, so we're going to save that. Oh yeah, so every time you save like an object that has a rotation or free movement, you can rebuild and save it. So that doesn't really affect your assembly. So we'll call it rail block system. All right, so now we can open a new assembly. Okay, so now you can see that you can input, like I said in our previous workshop, you can input sub-assemblies, so what we just created, into bigger assemblies. So in this case, I'm not going to start with that sub-assembly first. I'm going to actually start with the fixed bracket that we had. So here's our fixed bracket that we created, and I'm going to, so remember, every part you input first is always going to be fixed. So that's what we're going to use first. So I'm going to just use my scroll wheel to adjust the camera view. And I'm going to add the shaft next. Right, so we know the shaft is going to be connecting the fixed bracket to the wheel. So I'm going to click wheel. And basically I have 3 parts right now. Okay, so how am I going to connect all of these together? So I can use a mate. And what I'm going to mate first is I'm going to mate the outers or the face, so the circular face, to the fixed bracket, like that. So I'm going to click OK. So now you have your shaft inside the connection point, but this is free to move, right? Now you have to mate one of the faces on the edge of the shaft to, let's say, this face. So now this is locked in place. So you can rotate it like this, but it can't be translated in any other direction. I'm going to now click the outer part of the shaft and then click the inner circle of the wheel. So now that is also fixed as well, but now the wheel can move like that. So we have to add an additional mate. In this case, I am going to create, or I'm just gonna leave that for now, and I'll mate it later on once I introduce more parts to it. So we're gonna actually introduce linkage 1 first, but if you can't find it here, then you can always browse for your other parts. In this case, we have linkage 1 here. And I'll click on that, and I'll just put it in some random place. So this is all gonna fit in together. We're gonna add the other linkage as well, linkage 2. So with these connection points, obviously there's gonna be more shafts needed. So we'll add 2 more shafts, right? So 1 and 2. So for this one, we're going to focus on linkage 1. So we're going to create a mate, and it's focusing on this inner part of the circle of one section, so not the second section, and we're going to click on the outer face of that cylinder. We're going to click the check mark. And we're going to make this face touch this back face of the fixed bracket. So once you click both of them, it's going to basically touch. So now you can see that this linkage is now able or free to rotate. And then we're also going to do the same as well with this one. So I'm going to click on the shaft, click on this part. But I'm now going to create a distance mate. So this distance mate is basically making a distance between this face and this face. So before, like once you click on both of them, it automatically defaults to coincident. But let's change it to this distance mate down here. So when you click on it, you can adjust the distance. So let's say 5 millimeters. And that would adjust the distance between these two faces. Okay. So actually for this one, let me see. So let's look at linkage 2. And I'm going to do basically the same mate from the circle to the shaft. And then I'm now doing the front face of linkage 2 to the back face of linkage 1. So now they're touching. So now this kind of completes the two linkage system. We can see here, it's free to rotate like that. Okay, but we want to make it want to make it so it connects to this wheel. So how can we do that? We can make an additional mate of this shaft to any one of these outer holes because I had defined the distance of the linkage to be 36 millimeters, and that is the same as the distance of these two circles. So if I click on this and that, it automatically locks into place. So let me rotate the view. And I am going to make an additional distance as well. So to lock in this position of the wheel, I am going to create a mate from here, this back face of linkage 2 to here, the very back face of the wheel. So remember, its default is coincident, but we're going to use a distance mate, and I'm going to give it a distance of 25 millimeters. So now we have that. And I'm going to just do the shaft for this last one. And then I'm going to make a distance mate for the shaft as well. So I'm going to do it for the front face of linkage 2 to that. And I'm going to give it a distance of 15 millimeters, like that. All right. So now we have this. And then now I'm going to introduce our subassembly that we had, the rail block system. So what we had before. So I can drag it out, put it somewhere. So what I'm going to do with this. So because this black piece, the rail, has to be fixed, right? This, the block is free to rotate, but the two block pieces, right, the fixed bracket and the rail are supposed to be fixed. So we have to fix that. So when we fix it, we have to fix it relative to our original piece right here. So this is a bit tricky, but it's just inputting a lot of distance mates relative to the fixed bracket. So in this case, I'm going to do a distance mate between the front of the fixed bracket to the front of the rail. Oh wait, so let me click mate first before I do that. So if I do that, I'm going to give it a distance of, let's say, 15 millimeters. Okay, that distance is done. Now I'm going to do an additional distance from this bottom face. So this small square right here to this face right here. Right, so we use a distance mate again, and I'm going to input a distance of 67 millimeters. All right, so that is done. And finally is our distance from the bottom of these two. So this one is very specific. I'm going to put a distance of about 1.511 millimeters, like that. And hopefully that should work out fine. So right now, right, we inputted 3 distance mates for the rail to this fixed bracket, and now this can't be moved, right? I can't drag it anywhere. So now, one last touch is this piece. So we're gonna mate, if we zoom in, mate this circle, the inner part of the block to the shaft, and that should be concentric. And then we can just do an additional mate of the faces. And actually, I think that would over-define it, but we can double check. So if we zoom out, actually, I probably made a mistake somewhere. Let me double check. Oh, wait, okay. So for this object, you have to make it flexible. When you input subassemblies, they're automatically going to be rigid. So you have to right click your actually you can right click it through here. So on this side, right, where you inputted all your parts and now your subassembly, you right click on your subassembly and there should be a section here. So you make subassembly flexible. So you have to click on this to actually make your block flexible in your system. So if I make it flexible, then now this block is free to rotate. So now I can rotate it like this, and that basically completes your assembly. Does anyone have any questions? So that concludes our tutorial for this workshop.
How do you get the numbers for everything?
So the numbers is just like I would have taken a lot longer because I would have to do the math. There's a lot of math involved when it comes to figuring out those numbers. Like So like when I started out, right, I had to first look at the linkage and I wanted to make this hole for the slot the same or the same distance for the radius of the wheel. So this linkage can connect to one of these holes through a shaft, like right there, right? So then the next was just creating a longer linkage, like any length that I could decide. And then I would have to play around with it by clicking on evaluate, and I'd have to do a lot of measurements involved and try to get it to fit it in the right position. So it's like a step-by-step process. I wanted to show you all like the different features and different like ways of like using SolidWorks. But yeah, the numbers are kind of difficult to get because you have to make changes every time. It's not going to be like this where I just give you all the numbers. You have to kind of figure it out yourself. So yeah, hopefully that helps.
Yeah, I think some people are watching playback because, you go pretty fast.
Oh yeah, because like I didn't know like how long this workshop was going to take for me, like when I was going to do the everything. So like I guess I finished pretty early. Like we had like 10 more minutes left. But anyone have any questions or like anyone want me to go over anything again?
Give a couple of seconds because I think the live stream is also slightly delayed.
Okay.
So my guess is people will watch the video and then have questions.
I mean, it's gonna be posted on YouTube, so you guys can refer back to it at a slower pace. But yeah, obviously the dimensions is probably the most difficult part because you have to get it very precise. So let's say before I had, if I go to a previous, let's say I go back to the rail, right? I actually didn't start off with, uh, what did I have before? 86. I probably started off with like 100 millimeters, right? So let's say I start off with like 100 or something, and that would obviously mess up my entire thing. So every time you have to go back to something, you have to adjust everything that was connected to this part. So for example, if I adjust this single dimension, so I change from 86 to 100 in terms of the length of this rail, I would need to go back to the rail block system, right? Because now you increase your length, but your mating distance, so you set it to 72. So it still stops here. Even though you increase the length, you have to adjust accordingly by changing the mate. So before this limit mate was fixed for that specific part, now you have to edit that and you have to increase it by 10 because we added, or no, we have to increase it by 14 because it went from 86 to 100. So that means I would have to add 14 here. So that would be like 86, right?
Yeah. We have a question. It says, "Do you have 2D drawings with dimensions of the parts to practice off of?"
If I have 2D drawings,
Yeah.
um, I do not, but I can probably get 2D drawings. So let me finish this first really quick. So I adjusted it by adding 14. So now your limit distance has increased. So now it's fits perfectly inside the rail. So every time you make adjustments to previous things, you have to always remember what it connects to because it would always affect your final CAD. So you can always refer to, let me open up drawing. So we haven't covered drawing at all, but let me, let's say, yeah, this. So these are what professionals use in the workforce. When you make something, obviously you have to get it checked off by your superiors or like your boss or everything about your design and if everything fits perfectly. So let's say if I wanted to look at the rail, right? I can click on the rail and then I can just click on, yeah, I can click on the rail and I can click on like this sheet. So this is basically the top face of the rail. It's kind of bland because it's a rectangle. Oh wait, but now you can see the front face. So you can like drag it out and drag it to the side like this and drag it in your isometric view. Obviously it's not perfect, but you can kind of have an idea because you can incorporate dimensions to these. So you can actually show your dimensions here. I am not gonna go over this specifically, but if you guys want a workshop specifically on how to incorporate your assemblies into these drawings, I can do that in like another workshop.
Yeah, that's what I remember seeing always in the notebook.
Yeah,
That's usually what before that's what they would look for in the notebook was these assembly drawings or whatever. But anyone else time to win awards? Well, the notebook is a change, so it's a
yeah.
different world.
So this would be good if for your engineering notebook to show specifically like your dimensions and stuff, all the details that you put into your CAD drawings.
Yeah, it's 15 pages now, so pick your best 15 pages. So I
Oh,
would,
really? There's a page limit. Dang.
yeah, it's supposed to be like a portfolio thing.
Okay.
15 pages of everything that we used to do in those notebooks. Um, the question though is, does that mean front or back or just 15 pages?
Oh, that's a question for you.
Man, I haven't done that in a while, but yeah, I think one font size, yeah, font size 2 to fit everything. So we'll see, but thank you, Richard. Does anyone else have last second minute questions, or is it okay if they contact you?
Yeah, you guys can contact me through Discord, since all of you guys are on there. That's probably like the easiest for me.
Yeah,
Just like,
his name's Richard, right? Your name's Richard, right? Like on
yeah, I think you just say 542 on it, maybe. I have a picture of a dog with his head tilted.
very common. Most people's profile pics are their pets or a pet.
Yeah.
Um,
Yeah, so one last thing. Yeah, so I set the dimension because this dimension of 86 because of where it's located. So as you can see now, if this two-bar linkage has reached its maximum distance, there's this extra space here, and I didn't really want that, so I had to shift it inward to fit accordingly. You could also shift this rail all the way like towards, because there's this extra space here. To accommodate for this empty space, you can shift it to the right a bit or to the left a bit, and that could also work too. So it's based off of your preference. There's not really one correct way of doing this. It's just what works best and like I guess efficiently.
yeah, so this video will be posted on YouTube probably within this day. I'll leave the live stream up, but then I edit it and cut out stuff, so it's just the straight up video. And then you can message Richard if you have any more questions. I think that would be a good idea maybe later on to do like a drawing one or something.
Yeah, I can do that.
All right. Yeah, because we have them all booked all the way till the end of October already, so maybe November.
Hmm.
That gives a long time, so I won't bother you.
Yeah, that sounds good.
All right, I'm gonna end this. Hope everyone has a safe weekend and staying safe. Thank you, Richard, again so much for your time.
No problem.
All right, bye guys.
Bye, everyone.